Hi, we continue our discussions on light. Okay, we continue with question number 15. A student carried out an experiment to investigate the relationship between object distance u and image distance v for convex lens. And then using values of u recorded corresponding v, and then a graph of uv against u plus v plotted or is plotted as shown below. Okay, this is actually your paper 3, yeah? Question number 2. Alright, so the very first question normally will ask you for state the relationship between uv and also u plus v. Okay, so here is uv versus u plus v. So if I go to my graph, okay, so my x-axis is already in u plus v, and then my y-axis is already in uv. So what is the relationship? So we look at the graph. So this graph starts from 0, 0, and it is a straight line. So this must be directly proportional. Okay, so directly proportional. Okay, you can write a complete statement. You can also say that uv, okay, is directly proportional to u plus v. Okay, that will be a better answer. So when you answer this question, please be careful. Look at the axis first. Right, especially when this thing, your y-axis is given as 1 over something. Okay, so be careful with this. Don't simply say it is directly proportional. Right, we go to the next one. Determine the value of u plus v when the value of uv is 400. Show on the graph. So you see here it says show on the graph. When uv is 400, what is u plus v? So how do we go about solving this? So we go to our graph. Okay, we check for uv 400. Okay, so I have drawn my line here, dash line, and I draw a line going down, and I check. Okay, so my u plus v is 40. So you must draw this line here. Okay, this line you must draw because it carries 1 mark. Alright, so here you write the answer. U plus v is 40 centimeter. Okay, so the unit you can get from the graph. So for this paper, for paper 3, you must write the unit. Alright, if you only write 40, then you will lose the mark. No mark for you. Okay, now next one, from u plus v obtained. Okay, calculate v when u is 20. A very straightforward question. So u plus v is 40. Okay, it's from this one here. And what is v when u is 20? So u is 20 plus v equals 40. Then definitely your v is 20 centimeter. Okay, so again, make sure you write the unit. Okay, next question. Calculate the gradients of the graph. Show clearly on the graph how you obtain the values needed for the calculation. Again, here it says show clearly on the graph. Alright, so how do we go about solving these questions? How do we go about answering these questions? Remember that you must draw a very big triangle, right? So here I've drawn my triangle in blue, and then I put this mark here so that the marker know that you are using this triangle. All right, so the size of this triangle, it's either 4 by 4, okay, to be safe, right? So this 4 by 4, this actually means you are using 2 cm. So if I multiply by 2, then that will be 8 cm. multiply by 8 cm. Alright? Okay, so it's not enough just to draw the triangle. Just to be safe, you write the coordinate. So here is 0, 0, and then the coordinate here is here will be 45, right? Okay, so here is 45, and then my y-axis is 450. Okay, follow. So I write my coordinate as well on the graph. So next, let us answer the question, how do we find the gradient? So in mathematics, you have learned that gradient equals y2 minus y1 divided by x2 minus x1. That's what you have learned in your mathematics class. So just substitute the value. Alright, so just now I have two coordinates. I have 0 and 0, the origin, and the other one is 45 and 450. So that is my coordinate. So let's assume this to be point number 1, and here is my point number 2. So here is my x1, y1. Here will be x2, y2. So I just plug in the value. So my y2 is 450 minus 0, and then my x2 is 45 minus x1 is 0. Alright, so next, check the unit. What is the unit on the y-axis? Okay, so on my y-axis I have centimeter square, right? And then on my x-axis I have centimeter. Alright, so I go back to my work. So on the y-axis the unit is in centimeter square, and then on the x-axis it is centimeter. Alright, so now we solve the question. So that will give you 10, right? 10 centimeter. Okay, so cm you can cancel, so you only left with 1 cm. Okay, so we go to the next one. Given that the relationship between u and v and focal length, okay, by these equations, and then the next one it says using the equations and the gradient. All right, very important statement. So you must use this equation and you must use the gradient that you have found previously, and you are to determine the focal length. Okay, find the value of f. So we start by writing down the equation given. 1 over f equals 1 plus u plus 1 over v. Okay, 1 over u plus 1 over v. Okay, so that will be 1 over f equals v plus u divided by uv. Okay, follow? So if I go to my gradient just now, okay, m is the difference in y divided by the difference in x, right? And then my y is uv, and then my x is u plus v. This is what on my y-axis, this is my x-axis. So this is the gradient. You see here, it's v plus u over uv, but here I have uv divided by u plus v. So meaning to say, if I take the reciprocal of the gradient, I will get u plus v divided by uv. So meaning to say that v plus u or u plus v over uv, okay, is actually the reciprocal of my gradient. So now I can write this as 1 over f equals 1 over m. Alright, So you see, I am using the equation given and I am using my gradient. Okay, so next we just answer the questions. Okay, I draw a line here first. So I just continue from this one here. So equals 1 over m. So f equals m. So my m just now is 10 centimeter. Alright, so that is the value of my focal length. Okay, actually you can also use your mathematical skills. Alright, so from 1 over f, okay, you can try to compare it with this equation y equal to mx plus c, but in this case my c that would be 0 because I start from the origins. And you will also see that this m is actually your focal point 10 centimeter. You can try this one. Okay, so you have to rearrange this, okay, such that you will have uv as your y-axis and v plus u as your x-axis. Okay, so that one you can try by yourself. Okay, now state one precaution taken to ensure the accuracy of the experiment. Remember that this is the magic answer. The position of the eyes must be perpendicular, okay, to the scale of meter rule. Okay, so why I put here meter rule? Because if I go to the graph, I can see that I have to measure something whereby I have centimeter. It's a unit for length. Okay, correct. Length is this centimeter is a unit for length. So to measure length, I will need my meter rule. So that's why I chose down here to write meter rule as my instrument. Okay, so to avoid parallax error. So what I tick here is what you must write in your answer. The word scale must be written. Okay, and then the instrument must be written. Okay, so to know the instrument, you can go back to the graph and see what are the units. Follow. Okay, we go to the next question. So now you are given two diagram A and B, identical object passing through convex lenses. F is the focal point for each lens. So you are given these two lenses. All right, so one is a thin lens, one is a thick lens. Okay, underline the correct answer in the bracket to complete the sentence below. The image formed in diagram A and B is what? Okay, so for lenses, remember, if the object and the image are not on the same side, okay, so it must be real. But if I have mirrors, okay, if I have mirrors, then this image will become virtual. Okay, remember that lens and also mirrors, they contradict each other when it comes to virtual and real images. Okay, but here we have lens, okay, and my object and my image are not on the same side, then this image, it must be real. Okay, next one, compare the thickness of the lenses. So this is a very easy question. You need to compare the thickness. All right, so how do we answer this question? Remember that you are to compare, so you must write the quantity that you need to compare. In this case, the quantity is thickness of lenses, so you must have this, the thickness of the lens. Okay, in diagram A is lower than that of diagram B, than that in diagram B. Yeah, all right. So just look at the picture. So here is thin lens, here I have thick lens. So compare the thickness. So you simply say that the lens in diagram A is thinner than the lens in diagram B, right? Okay, so we write the answer. The thickness of the lens in diagram A is lower than that in diagram B. So next one, the focal length. Okay, the focal length. So the focal length would be from the optical center to my F, or from F to F, also my focal length. So just compare between these two pictures that I can see that the focal length in diagram A is greater, right? Okay, so we go back to the question, compare the focal length. So the quantity to be compared is focal length. So I have my focal length written in my answer. So the focal length in diagram A is higher than that in diagram B. Okay. If you notice that when I write my answer, I keep it consistent. I write diagram A first. Diagram A first here. You see? It doesn't have to be that way, but it is to ease myself when I have to answer the next question. Okay? So far, can you follow? Okay, next. State the relationship between thickness of lenses and focal length. Okay, so previously you were asked to compare the thickness and the focal length, right? So thickness and focal length. So you see here, diagram A is lower. Diagram A, when it comes to focal length, it is higher. So the lower the thickness, okay, the thickness of the lenses, the higher the focal length. You see, the lower the thickness, the higher the focal length. That is the reason why I keep it consistent when I am comparing. All right. So let us move on. Okay, so based on diagram A and B, okay, and the thickness of the lenses, compare the power of lens. All right, so how do we measure or how do we calculate power? So power equals to 1 over focal length. All right, so if I have a lower focal length, if we have a smaller focal length, then the power must become greater. Okay, the lower the focal length, then the greater the power, right? So first compare the power of the lenses. Okay, so if I go back to my pictures here, okay, here my F is greater, therefore my power will become smaller. Down here my focal length is lower, therefore my power is greater. So you are to compare the power, okay, the power for these two diagrams, right? So the power in diagram A is lower than the power of lens in diagram B, correct? Okay, so we just write the answer. The power of lens in diagram A is lower than that in diagram B. Simple, right? Okay. So again, I'm keeping my answer to be consistent. I write diagram A first and then diagram B, just like before. And then here the quantity to be compared is power. So I have power of lens in my answer as well. Okay. Now, the next one, state the relationship between the focal length and the power of lens. Okay, so here diagram A, the power of lens, it is lower. If I go back to my focal length just now, diagram A is 1. Okay, focal length, diagram A is higher. So how do we write the answer? The higher the focal length, the lower the power of lens. Okay, can you follow? Maybe I reduce the size. You see here, focal length greater. Okay, so the higher the focal length, the lower the power of lens. Okay, I hope you can follow the explanation there. So let's continue to the next question. Diagram C shows an astronomical telescope that is used to observe the distant object. So based on the lenses in diagram A and B, which one is the most suitable lens to be used as an eyepiece? Okay, as an eyepiece. Remember, for telescope, we have objective lens and we also have our eyepiece. So both of them, they have their own focal length. So for telescope, okay, for telescope, how is our FO and FE? Okay, so for telescope, we are looking at distant object, very far object, then the focal length of the object, objective length, must be greater than the focal length of the eyepiece, right? So if we go to our diagram A and diagram B just now, okay, which one has a lower focal length? Okay, so definitely diagram B. Okay, so maybe we can write a better answer here. Lens in diagram B lah. Huh? Okay, why we choose the length in diagram B? Because the focal length of eyepiece must be shorter than that of objective lens, so that a real and magnified final image can be produced. Okay, so the main reason actually is FO must be greater than FE. This is for telescope. However, for a microscope, remember, if I have microscope, okay, for a microscope, FO must be less than FE. Because for microscope, the object is put just underneath our microscope, right? So the distance is very near. All right. So we just move on to the next question. Okay, this is extra problem. Diagram shows the side mirrors of car which help the driver to see object behind the car more effectively. Okay, so we are talking about this side mirror. Okay, so what type of mirror is used? So this one is definitely convex mirror. Okay, give one reason for this type of mirror. So the reason is you will have a wider field. Oops. Okay, wider field of vision. Okay, can be obtained with a convex lens. Okay. So C in diagram below, F is the focal point and AC and C is the center of curvature of a convex mirror. So complete the ray diagram to show the positions of the image form, remember? So first I draw a line parallel to my principal axis, alright? And then you see here I draw my pole, okay? Because normally we don't draw it straight until it hit the mirror. So we draw a line here to represent the pole of the mirror. Okay, so here is our pole, our reference line actually. Okay, so up to this point here, the ray, this coming ray, it will be reflected. Okay, it will be reflected upward. If I go straight, you can see definitely it will be reflected upward. Okay, reflected as if it comes from this focal point. Okay, so we have done this before. So that's my line number 1. Okay, and then if I go to my line number 2, I draw from the head of this object, and then I use this C here. Okay, so what happens if the light goes through and hitting my point C, the center of curvature? Okay, the incident ray, it will be reflected on the same line. Okay, and then what's next? Find where the red line and the orange line intersect. So it intersect here. Okay, so I will have my image here. So this is my image. Follow? So remember, for a mirror, in order for you to know which F and C to be used, you complete the circle of this mirror. So you are going to use this F and this C. Okay, now state 2 characteristic of the image form. Okay, if I look at my image, I know that my image is diminished. It becomes smaller. And the next, I know it is also upright. Okay, the orientations of my image is upright. It's just like my object. Okay, now, is it real or is it virtual? Okay, so for mirrors, if the object and the image are not on the same side, then this image, it must be virtual. Okay, but if I have lens, okay, if we have lens, if my image is here and then my object is on the other side, for lens, this image is real. Okay, but for mirrors, the image is virtual. Okay, remember I said, and I keep on repeating, that when it comes to real and virtual, mirrors and lenses contradict each other. Alright, we continue with question number 18. Diagram A and B shows an identical pencil is immersed in distilled water and seawater respectively. So based on diagram A, compare. Alright, easy question, compare. So the quantity to be compared is the bending of the pencil. So I have the bending of the pencil in my answer. Okay, so the bending of the pencil, if I look at my diagram, I can see that the bending is greater in B. Okay, compared to A. You see here, the distance of deviation here is greater, but here is smaller. So the bending of the pencil in diagram B is greater. Okay, so next one, compare the density of distilled water and seawater. So I write the quantity to be compared, the density, okay, of the distilled water and seawater. So the main quantity is the density. So the density of seawater in diagram B, you see here my diagram B. Here I have my diagram B. So I mention my diagram B first. Then I mention my diagram A. Okay, so the density of seawater in diagram B is greater than distilled water in diagram A. Okay, so in diagram B, the bending is greater. And then the density, diagram B, is also greater. So next, we go to the next one. State the relationship between densities of water with the bending of the pencil. So you can see here, the greater the density of water, the greater the bending of the pencil. Okay. Based on diagram A, compare the size of the observed pencil inside and outside the distilled water. So here you are asked to look at distilled water only. So don't look at the other one. Okay, don't look at the seawater. So you are just looking at diagram A. Compare the size. Okay, so just compare the size on diagram A here. So I can see that inside the water the size is bigger, outside the water the size is smaller. Alright, so the quantity to be compared is the size of the observed pencil inside and outside. So we are talking about the size. So how do we answer this? The size of the observed pencil inside the distilled water is greater than that of the outside of the distilled water. Okay, now name the phenomenon shown in diagram A and B. So this is refraction. Okay, refraction of what? Refractions of light. Okay, next one, underline the correct answer in the bracket to complete the sentence below. The phenomenon in C, okay, so we are talking about the refractions of light, happen because of what? Okay, it's due to the change in the velocity of the light. Okay, next one, diagram C shows a coin, okay, in a beaker filled with water, and then you have to draw a ray diagram. All right, so this is very easy question. So this is my coin. Okay, so I simply draw anywhere up above the coin, okay, to denote where my image will be. So this is my image. Okay, so from this image I draw two lines. Okay, two lines going to my eyes. Okay, so this line is going up. Remember that our eyes do not emit light. Our eyes receive light. Okay, so I just draw two lines going to our eyes, and then at the point of intersection between these lines with the surface I draw my normal. Okay, so let's make the picture a bit bigger so that you can see clearer. Okay, so I draw, so this is my normal. Okay, same thing goes to this one, is actually our normal. Okay, so this line here, okay, here is air and here I have water. So what happened to this light as we enter the water? Water, the density is greater, therefore the light, it must be bent towards the normal. So you see here, my line here is bent towards the normal. Okay, if I look at my this to my blue line here, when as this line enter the water, okay, my line is bent towards the normal. Okay, follow? So I know it must be bending, it must bend, and it must hit my object. Alright, so next, after you have drawn these two lines, so you show the directions of the light propagation. Okay, so that's how we draw the ray diagram here. Okay, let's move back. Okay, we go to question number 19. Okay, diagram A shows light ray incident into a glass block. So based on diagram A, the angle of 42 is known as what? You see here, the light as it enter air, it fall on the surface between air and glass. So what we call this angle, that is our critical angle. Okay, calculate the refractive index. So the formula is n equals 1 over sine c. Alright, So n equals 1 over sine of 42 degree. A very easy question, right? So n equals 1.49. Okay. Next, the light ray is adjusted so that the angle M is now 48. So remember that our critical angle just now is 42 degree. But now my incident angle is 48. Okay, so my I is greater than C. Okay, so the angle of incident is greater than the angle of the critical angle. So what happened? So we will have this light. It is not going out. Okay, it won't fall on the surface because my eye is not equal to C. Instead, it will be reflected. Okay, so the angle here is also 48 degree. So this happens if my incident angle is greater than my critical angle. Then you are going to have total internal reflection. Okay. So explain your answer in B1. Okay, that one we have mentioned. Incident angle is greater than the critical angle. Therefore, total internal reflection takes place. Alright, now we move on. Diagram C shows the light ray propagating into glass block. In diagram C, complete the propagations of the light ray. Okay, so I know air, the density of air is less than the density of glass, definitely, right? So I know that the light is entering a more dense area. So what happened to the light? Instead of it's supposed to go straight, right? But since it is entering a more dense area, so it must be refracted towards my normal. So here is our normal. Okay, so you must draw a line that is closer to the normal. So here is my refracted ray. Okay, so what happened to the angle of refraction if a denser glass block is used? So the angle of refraction, okay, here is our angle of refraction R. Remember, the angle is always measured with respect to the normal. So what happened to the angle of refraction if a denser, okay, glass block is used? So that angle will decrease. Right? In bahasa Melayu berkurang, don't write berkurangan, write it as berkurang. Okay, we go to the next question. Diagram A shows phenomenon of light on mirrors P and mirrors Q. Okay, and then CX. Okay, CX is the radius of curvature, and then F is the focal point. Okay, what is the meaning of focal point? So focal point is the point on the principal axis which all parallel rays are converging to or diverging from. Okay, so you can write this as the answer. Alternatively, you can also say that the focal point is the midpoint between the center of curvature and the pole of the mirror. Okay, if I am to compare these two answers, I would say that this is a better answer because it refers to my diagram. Okay, so what is my focal point? So the focal point is the point on my principal axis which all the parallel rays are diverging from. Okay, it's diverging from. If I look at my picture. Okay, now we move on to the next one. Observe diagram A and diagram B. Compare the curvature of the mirrors, the focal length, and the effect on the angle of reflection. And then state the relationship between the curvature of the mirror and their focal length. So in this one here, I'm using a table to answer. So what are we to compare? First is the curvature of the mirror, second the focal length, and then third the effect on the angle of reflection. You see here, first the curvature, second the focal length, and then third angle of reflection. Okay, now curvature of mirrors. Okay, curvature of mirrors in bahasa Melayu is kelengkungan cermin. Okay, so you compare the curvature of the mirrors, which one is more melengkung? Okay, A is more curved, right? Compared to B. Alright, so I simply write A is greater, B is lower. Now next one, the focal length. Okay, the focal length. So F is my focal point. So X to F is my focal length. Okay, so X to F here is my focal length. So just by looking at the picture, compare the focal length. So I can see A is lower, B is higher. Alright, so we just write in our table A is lower, B is greater. And the next, angle of reflection. Okay, so we go to the picture again. Okay, now compare the angle of reflection. So just very easy to look at this. I'm not looking at this point here. I just look at this point here. You see here the angle here compared to the angle here. So I can see that the angle here is greater. Here is lower. Okay, follow. Actually, when it comes to that question just now, we are supposed to look at this point here. If I draw my tangent line here, and then I draw my normal, so here is my angle of reflection. Here is my angle of incident. Okay, remember that if we are to apply our law of reflection, okay, the law of reflection, hukum pantulan, says that I must equals R. Okay, so we go back to the question. So the angle of reflection is greater in A, lower in B. Okay, so we have answer 1, 2, and 3. If we read on, state the relationship between the curvature of the mirrors and their focal length. So that is the fourth part in the question. So here is number 4 here. Okay, so the curvature of the mirrors, okay, we want to relate this and the focal point. Okay, you see here, the greater the curvature of the mirror, the lower the focal length. All right, so the greater the curvature of the mirror, the lower the focal length. Very easy, right? Okay, let's move on to the next one. Diagram C shows two cars R and S traveling in opposite direction. Okay, passing sharp bend. A mirror is placed at X. So here is our X. Okay, name the type of mirrors at position X. So that one definitely is a convex lens. Okay, the same mirror that you see in supermarket like King Hawk lah. Okay, so convex lens, it has a wider field of vision. So explain how the mirror is able to help the driver of car R to see car S. So first I will mention that the mirror has a wider field of vision, and then next one I would mention reflection, whereby the light rays from car R is reflected, okay, reflected by the mirror to the driver in car S. Therefore, the driver in car S will see an upright image of car R inside the mirror. Okay, so that's how I answer the question. Okay, next one. As a scout, you intend to design a solar cooker that can be used to boil water using direct sunlight. Suggest and explain how to build a solar cooker which can boil water in the shortest time based on the following aspect. So you are lucky here you are given the aspect, okay, to be examined. But first look at the objective. What is the objective of our design? Okay, can boil water in shortest time. Okay, so aspect, mirror, position of the water container, the material used for the cooker compartment, and then the color painted on the outside and inside of the solar cooker. Okay, so if I look here, I have 1, 2, 3, and then outside 4, inside 5. Okay, in fact, for material here, we can have more lah. Oh, so I will just build a table. So the aspect I just follow what is given in the question. You see here type of mirror and then position. Okay, I have position, material, I have material, and then the color outside and then the color inside. So these are the aspects to be examined. Okay, so first type of mirror. So what's your choice? What do you choose? Okay, which one is more suitable? For mirror, we have three, right? We have concave, we have convex, we have plane mirror. So for this one, I will choose concave mirror. Okay, mirror that looks like this, so that when lights come, it will be reflected, hitting our focal point. Okay, so here at this point here is my focal, my focal point. Okay, so I choose a concave mirror to focus sunlight to maximize the heating. So here is 1 point and here will be 1 point. Okay, next one, the position of the water container. So I'll put it at the focal point. Okay, you see here all the light, it goes to my focal point. So I will put my water container at focal point. The reason is all parallel rays are reflected and focused at the focal point, and hence we will have the maximum heating. So here is 1 point, here is 1 point. Next one, material used for the cooker compartment. So the material I will choose low specific heat capacity. Why do I choose low specific heat capacity? Because it will heat up faster. Okay, it can keep very little heat, so that's why the temperature will increase very fast. Okay, if I have a low specific heat capacity material. And then the outside color, I will choose black. Reason, it can absorb heat. And then inside, I'll choose shiny. Why shiny? Because sunlight can be reflected back into or onto the cooker. Okay, so here I have 10 marks. Okay, so for the characteristic, 1 mark each, and then for the explanation, 1 mark each. All right, so we move on to question number 21. Diagram shows Ali standing at the side of a pond. Ali can see the image of the fish and the image of the dragonfly in the water as shown by the ray diagram. Alright, what is the meaning of virtual image? See, very easy question. So virtual image are images that cannot be formed on a screen. Okay, so that is our virtual image. Now, A2. Explain how Ali can see the image of the fish and the image of the dragonfly, and then state the phenomenon of light that is involved in each case. Okay, now let's look at the picture. Ali can see the fish. Why? You see here, the fish is supposed to be here, but Ali see that the fish the fish is at this position. This is due to refraction. Alright, now you see the dragonfly here. Look at the ray, it goes here and then going here. So what is this? Alright, so this one here, it must denote reflection. Okay, same medium, but here I have different medium. Okay, the light ray from the fish in the water and then emerges out from the water into and goes into Ali's eyes. All right, so the ray is moving from water to the air, different medium, so that must be refraction. But here, okay, from air and then to air until it hit the eye of the observer. Okay, so it's the same medium. Okay, so here definitely I will have reflection. To be exact, this is actually total internal reflection. Okay, so now we go to the explanation. Incident ray from the fish is refracted away from normal at point B. So this is refractions of light. Okay, so 1 point, 1 point, and then the incident ray from the dragonfly is reflected by the water surface at point A. Okay, so this is reflection. Okay, to be more specific, it is total internal reflection. Okay, next one. Calculate the angle theta and also alpha, given that the refractive index is 1.33. Okay, let's go to the picture first. I believe we are also given the values. Okay, so here 40 degree is already with respect to the normal. Here I have 30 degree, but it is not with respect to the normal, right? So what is the angle with respect to the normal here? Okay, so here is 60 degree, because this one here is supposed to be 90. Yeah, so if here is 30, then here must be 60. So the angle I here is 60, and then theta is our angle of reflection. Okay, and this 40 degree here is the angle of incident for our refraction of light. Okay, and alpha here is the angle of refraction, because our theta, our alpha is already drawn with respect to the normal. Our theta is also drawn with respect to normal. Okay, so let us go continue on solving this. So just now our theta, that will be 90 minus 30, that will be 60 degree. Okay, it's very straightforward. If I go back here, if our I is 60, then this is our R, right? So our R must equal to 60, because the law of reflection says that I must equals R. Okay, law of reflection, hukum pantulan, says that I must equals R. So this theta must be also 60 degree. Okay, so that is our theta. Okay, next one is we want to find alpha. We are given the refractive index of water. Okay, so N equals sin or sine alpha divided by sine of 40 degree. Okay, if you are not very sure which one supposed to be the denominator and which one supposed to be the numerator. It's very simple. Okay, if I go to my picture, I can see that alpha is greater than my 40 degree. So alpha is greater than 40 degree, right? So if let's say I have sine 40 versus sine, let's say alpha is 60. Okay, you check these two value, you can see that sine 60 is greater than sine 40. Okay, so and remember that our n, it must be greater than 1. Okay, so in my formula I have to write sine alpha divided by sine 40, so that my n is greater than 1. In this case is 1.33. Okay, so sine of alpha divided sine of 40 degree. So now you can calculate your alpha, and your alpha is about 58.75 degree. So that is your alpha. Okay, next, state one characteristics of the image of the dragonfly. So what we have just now is reflection, right? That is reflection. So for reflection, this surface here will act just like mirrors. So what are the images characteristics of mirrors? Okay, so first it is virtual. Plane mirrors, virtual, and then next it must be same size. And the next one, laterally inverted. Okay, and the next one, same distance with object. These are the characteristics of images formed by a plane mirror, because the surface of the water now acts as if it is a plane mirror. Okay, but you don't need to write all this because the question only asks for one characteristics. Alright, so we move on to the last question. Table below shows the design of the torchlight P, Q, R, S, and T. Okay, you are asked to investigate the characteristics of the 5 torchlights shown in the table above. Explain the suitability to determine of each characteristics of the torchlight and determine the torchlight which can produce strong parallel beam of light. Okay, so the objective is strong parallel beam of light. Okay, so the characteristics of the torchlight. So if I go to my picture, okay, I need to find what are the differences that I can find in the picture. Okay, so you see here the reflector. Okay, I have concave reflector. Here I have convex reflector, and then here I have plane reflector. Okay, so 3 choices. So I choose concave reflector. Reason, so that reflected ray are converged onto a single point, producing strong light. Okay, why strong light? Because all rays are focused onto a single point. Okay, you see here strong light, strong parallel beam of light. That's the reason why I choose concave reflector. So here is 1 point, here is 1 point. Okay, now bulb at focal point. Okay, so if I go to the picture, bulb beyond focal point, bulb at focal point, bulb at the pole of the mirror. Okay, these are the differences, right? So which one are you going to choose? Okay, in this case we are choosing our bulb at focal point. That's 1 point here. Why you choose that? So that the reflected rays form a parallel beam. Alright, so remember that if I have a concave mirror, when it comes to drawing, I'm very poor. Okay, if we have a concave mirror, and then suppose here is our principal axis, here is our F. Remember that all line that pass through F, it will be reflected parallel to our principal axis. So here is mirrors, concave mirrors. Alright, and then for the third one, we are talking here about the batteries. Okay, so we'll look at the picture. Okay, battery here I have in series, here series. Okay, here parallel, here series, here parallel. Okay, so we have two choices. So which one do we choose? In this case, I choose the batteries are in series. Why? Current is larger. And then the fourth difference that I can see in the picture is the connecting wire. Okay, so in the picture, the connecting wire that we have iron, we have constantan, we have copper here. Okay, so we have three choices. So which one are you going to choose? Okay, if I were you, I would choose copper. Wire normally is copper, kan? Right? So why I choose copper? It has low resistance. So if I have low resistance, the current must be larger. Okay, so here are all the characteristics that I am choosing. So now we go back to the picture and we mark all the characteristics that we have chosen. Okay, so just now we have chosen concave reflector. Okay, concave reflector, bulb at the focal point, battery in series, copper connecting wire. Okay, so we just mark it on the picture given. Okay, like this one, only copper connecting wire. And then next one, you have to count how many tick that you have made. For example, here I only have one tick, so one. Here I have four tick, so I have four here. All right, and then you compare the number of tick. P only one tick, Q I have four tick, R one tick, S one tick, T one tick. So which one has the most tick? Okay, Q. So the chosen one is Q. Right? So as for the answer as for our selection, torchlight Q is chosen. That is 1 point here. Okay, and then give reason why you choose Q. Simple, you just repeat what you have said before that. Because it has concave reflector. The bulb is at the focal point. The batteries are in series. The connecting wires are made of copper. Okay, so I'm just repeating what have been written before that, right? So here is 1 point. All right, so let's count how many points. 1, 2, 3. Okay, maybe I put numbers here. 1, 2, 3, 4, 5, 6, 7, and then here is 8 for our reason for choosing copper connecting wire. Here is 9, so here is 10. So this question carries 10 marks. Okay, so we are done with light, and definitely we are also done with revision for our Form 4 syllabus. So we stop here, and after this we will meet again. We will discuss trial exams from Kelantan. Okay, so I see you again next time. Bye bye.